In this video, we're going to write the equation of a parabola using the focus of a parabola, and this is going to be a different kind of definition of a parabola. So let's go ahead and get started. And what we can do, or let's look at this. It says previously you learned that the graph of a quadratic function can open up or down, and that it is a set of all fixed points in a plane that are equidistant from a fixed point called the focus and a fixed line called the directrix. And let's take a look here at this picture. And what we see, we have a line here at the bottom called the directrix. We have a focus of a parabola, which is inside the concave shape. And by this definition of a parabola, when the distance from the directrix to a point is the same distance from the focus to a point, that's going to form a parabola. So we could see right here that the point on this parabola right here is the same distance from the focus as it is from the directrix. Take a looking at this other point further up, we can see again that this distance from the focus to a point on the parabola is the same distance as the directrix to that point on the parabola. And if we keep that up, there would be an infinite number of points like this. That's what forms a parabola. And a couple definitions or things we should be aware of is that the vertex then is going to be halfway between the focus and the directrix. So whatever distance this is to the vertex, this distance has to be the same. And once again, the directrix is this line, and it will be perpendicular to the axis of symmetry of a parabola. Here's the axis of symmetry. It comes down, cuts the parabola in half, and the directrix will be a line that's perpendicular to that. And then what we can do is we can use this definition to write an equation of a parabola. It's kind of cumbersome, but we could do it. So here's an example, and we can see that we have a focus here at 0, 2, which means that the directrix would have to be down here at a -2 in the y, because look at this. This is on the y-axis. We have a point 0, 2. The vertex is actually on the point 0, 0, so the focus is 2 points above, or 2 units above in the y direction, which means the directrix would have to be 2 units below because this distance would be the same. So if the focus is 0, 2, this would be y is equal to a -2. And let's go ahead and write the equation of this parabola. So what we know is, let's take a look at this point that they've identified for us out here on the parabola. We draw a line straight down. We have the point x minus 2. And if we go over toward the focus, we would have this line equal to this line. So let's go ahead and use the distance formula. So for this line right here, the distance, or the length of that line, would be square root of x1 minus x2 squared plus y1 minus y2 squared. So, and that would be equal to the line here, which would be the square root also of x1 minus x2, y1 minus y2 squared. And let's go ahead and plug our points in. So for this part right here, I'm going to say x minus x squared plus y minus a -2. That would be y plus 2. For the other point, I would have x minus 0, the x value minus this x value, squared, that should be a plus y minus 2 squared. Okay, let's continue with this. right, so let's work inside the this parenthesis, or the square root sign. X minus x squared, that's 0 squared. Well, that's going to go away, so we're just going to have x plus 2 squared here. And on the other side, I'm going to have x minus 0 squared. That's going to be x squared plus y minus 2 squared. Now what I'm going to do to get rid of these square roots, I'm going to end up squaring both sides. What I do to one side, I can do to the other side. So I'm going to end up with y plus 2 squared is equal to x squared plus y minus 2 squared. And now we have to be able to do binomial multiplication. So that would be the same thing as y plus 2 times y plus 2 is equal to x squared plus y minus 2, y minus 2. Over here, we are going to have, if you work this out, you're going to have y squared plus 4x plus, whoops, plus 4 is equal to x squared plus, now if I would multiply this by FOIL or by the distributive property, I would have y squared minus 4y plus 4. Okay, let's continue on. So let's subtract y squared from both sides. That gives me 4y plus 4 is equal to x squared minus 4y plus 4. Let's add 4y to both sides. Okay, now I have 8y is equal to 8y plus 4 is equal to x squared plus 4. If I subtract 4 from both sides, I get 8y is equal to x squared. Now divide both sides, or we could take both sides times 1 over 8 to get rid of the 8 here that's a numerator. Now I end up with y is equal to 1/8 x squared. Okay, let's just briefly think about what we just did there. Is we actually knew the value for p, and based on that we were able to use the distance formula to write an equation of this parabola that was given. Now we don't always want to do that. We don't want to go through the trouble of writing the distance formula. So what happens if we say, well, let's just use some generic value, p, okay, that's going to be the y-coordinate of this focus. And that means that the directrix is going to be a negative p on the other side. So I'm not using any numbers, I'm just using letters and variables to represent this. Hopefully I can come up with some generic formula that I can use. So if you use the distance formula on this particular parabola that now that just has like letters and no numbers, you keep using the distance formula, you get this formula right here. And this is the important formula that is the equation of a parabola when we know p, and p of course is the distance from the vertex to the focus. It is the value for a parabola that opens up like this parabola is opening up, that p would be the value, the y value of the coordinate, right? So this would be 0p. And here's the formula. That's the parabola formula which we need to know. Okay, so this is really important. And that works for values that make the parabola open up or down, which we would expect it to do because, look, it has an x squared. We know when x squared, we've graphed those before, the parabolas open up or down. If I would happen to have a parabola that opens left or right, we will have those now. And of course, those are not going to be functions. They do not pass the vertical line test, but we still have those. We still have to learn about those. But in that case, notice what's different. Here's the formula for parabolas that open left and right. In this one, the y is squared and it's x that is not. So let's look again. These are for the parabolas that we know opening up or down. These are for the new type of parabola we have that open left or right. If there's going to be a negative out here, the parabola will open left. If it's not a negative, it will open to the right. If there's a negative in the ones that have x squared, it will open down, just like before. And if there's not a negative, it will open up. Okay, so a summary of all that is in this table. This table is out of your text. And you need to, I'm going to stop here for just a second, so if you need to pause it, you can. But this is a table that you just need to really look at and try to understand all the parts about it. And I'll just briefly talk about a couple things, and I'm going to move on for some examples. So this would be an example of equation y equals 1 over 4p x squared, where p is going to be the value of the focus. It's x squared. It's going to open up. When p is greater than 0, well, p will move up along the y-axis, so it's going to open up. The directrix will be at a negative p. Okay? If p is less than 0, that means this p will actually be a negative. That's going to make this whole term negative. The parabola will open down. The focus will then be p units downward, because the actual p value here will be a negative number, like a negative 3. Okay, so let's just think about that. If this p was actually a negative 3, then that means my directrix up here must be the line y equals to 3. Okay, let's look at one of the ones that has a horizontal axis of symmetry. For these, remember, they're opening left or right. The y will be squared. The x is not. So if, let's just say that this value right here for the focus, and notice that it's moving along the x-axis, so the p is actually in the x position. The p value is in the x position. So if this would be, the focus would be the point 5, 0, that would work. Then the directrix would be the line, this is a vertical line, x equal to a negative 5. Okay, let's work some examples. Okay, identify the focus, directrix, and axis of symmetry of this particular equation. So notice the y is squared, so we want to get all the numbers on this side, x equal to something on the other. So let's go ahead and start this. I have a negative 2x is equal to y squared. We need to get it to be x equals, so what I'm going to do is I'm going to take this side and multiply it by the reciprocal of a negative 2, that would be a negative 1/2, and take this side and multiply it by a negative 1/2. That's going to give me the equation x is equal to a negative 1/2 y squared. There's the equation of my parabola, written in its standard form. Right now I need to plot the parabola and find out some important characteristics of it. So what I know is that the basic standard form of this parabola would be something like x is equal to a 1 all over 4p y squared. Now what I actually have is x is equal to a negative 1/2 y squared. So what I need to do is find the value of p. Okay, so if this is what the standard equation looks like, this is what my equation looks like, these must be equal to each other, right? So let's go ahead and work it out based upon that knowledge. So I know that 1 all over 4p must be equal to a negative 1/2. Now, I need to get the p from a denominator to a numerator. So let's take this side times 1 over p, times p, and then I have to take this side times p. Since p is a denominator, p is a numerator, they'll go away on this side, and what I'll have over here is 1/2 p. So what I have left is 1/4 is equal to a negative 1/2 times p. Now, to get rid of the negative 1/2, because I want to find out what p is equal to, I'm going to multiply both sides by the reciprocal of a negative 1/2. That would be times a negative 2. So what I'm going to have is I'm going to have a negative 2 times 1/4. That is a negative 2/4 is equal to p. So that would actually be equal to a negative 1/2. So I found my value of p. Okay? Now remember, let's look at this, and we see that it is going to open left or right, and because of the negative sign, it'll open to the left. I know my value of p, it's a negative 1/2. So my focus will be on the x-axis, and in fact, it's going to be right here. So the focus is going to be at a negative 1/2, 0. The directrix, and of course my vertex, is at 0, 0. The directrix, since the focus is a negative 1/2 to the left, the directrix will be the line at a negative 1/2 on the other side, or a positive 1/2 on the other side. So this directrix would have the equation of x equal to 1/2. Okay, so I've got a lot of information already, but I need to get a couple points. So let's go ahead and plot a couple. And how we're going to do this is if I pick an x and find y, I'm going to have to take square roots. I don't want to do that. So if the y part is squared, I'm going to find y. I'm going to pick a y and then find what x makes that work. So really, I'm going to pick the value of whatever the squared term is. So let's go ahead and do that. So here's my equation. X is equal to a negative 1/2 y squared. And like I said, I'm going to pick the y in this case and get the x. So if I pick a y value of 4, substituting 4 in to this equation, I get 4 squared. That's 16. 16 times a negative 1/2 gives me a negative 8. Let's pick y equal to a negative 4. So if I pick y equal to a negative 4, I get a negative 4 squared. That would be 16. 16 times a negative 1/2 is also a negative 8. So I have 2 points. In general, you want to pick values for the squared term that when I divide by the term that's in front of it, give me a nice number. I could see that if I squared 4, that would give me a value that when divided by 2 would give me a nice number. For example, if this would have been 1/3 over here, I probably would have picked 3, so because 3 squared is 9. So that's kind of how I do that. Anyway, let's go ahead and plot these 2 points. I have a negative 8, 4, negative 8, negative 4. So my parabola is going to look like this. Okay, let's go on. Here's an example in the book. So you can see how they did one. If you need to stop it and take a look at it, now's a good time to pause it. Okay, let's go to where we're writing an equation of a parabola. This is actually going to be easier than graphing it. Okay, notice what I have here. This parabola opens up or down. I'm going to be using the equation form where it's the x that's squared. So the equation that I'm going to use is y is equal to 1 all over 4p x squared. Let's find p. Okay, so let's look at what we have. The vertex should be at 0, 0. The directrix is at a negative 2.5. Okay, so that means that the focus would actually be 2.5 on the other side. So my focus would be equal to 0, 2.5, and p would be equal to 2.5. So let's just put 2.5 into this equation. I get y is equal to 1 all over 4 times 2.5 is equal to x squared. 4 times 2.5 is 10, so I have 1 all over 10 x squared. There's the equation of my parabola. Okay, let's take a look at the one they have in the book. So for the one they have in the book, you can see that what we have here is a vertex at 0, 0. The directrix right here will be at 3, right? So the directrix would be the line y equal to 3. So the focus would be down here at the point 0, negative 3. So p must be equal to a negative 3, right? And that's what it shows. P is a negative 3. So when I put a negative 3 into this value for p right here, that would be 1 over 4 times a negative 3. That would be 1 over a negative 12. So my formula would be that, or the equation would be what's shown. So actually writing the equation of a parabola is pretty simple. Okay, here's a couple more examples. Here I have a focus at a negative 8 and a directrix at a positive 8. So what's my value of p? Okay, p is equal to negative 8. Now what way does this parabola open? Let's think about it. The focus as it is 0, negative 8. So 0, negative 8. That's opening downward. Okay, so this is going to be an x equals y squared. And I know the value of p. P is a negative 8. So this will be x is equal to 1 all over 4. Now p is a negative 8. Y squared. X is equal to 1, a negative 1 over 32 y squared. Okay, let's look at the next one over here. The focus is 0, 1. So that's going to be a parabola where the focus is 0, 1. The focus will be up here. So it's going to be opening upward. Wait, this last one I did wrong. Hang on. Let's redo. Okay, the focus is at 0, negative 8. The parabola opens down. P is a negative 8. Since it's open down, this is y is equal to 1 all over 4px squared. So this would be y is equal to 1 over 4 times a negative 8x squared. Y is equal to negative 132x squared. This one with a focus of 0, 1, that's going to open upward. That would also be a y is equal to 1 all over 4px squared. And in this case, the p value, because here's my focus at 0, 1, p is 1. So y is equal to 1 all over 4 times p, which is 1, x squared. Y is equal to 1/4 x squared. Let's see if I have a few more examples to work. Actually, what I'm going to do is I'm going to stop here for the lecture, and I'm going to just work some examples in a separate video lecture.